So today we're looking at solving quadratic equations graphically, which means that we are going to be solving our equation of whatever our quadratic is equals 0 and looking at how we can get that solution on our graph. So this ax squared plus bx plus c, this is our general equation for a parabola. And that is how we say it. It's a parabola. Now, what's unique about the parabola that we can see to the right, it's obviously not a straight line, so it's not linear. And we can see that it's a curve. So both of these are ongoing. They don't just randomly stop there. What's unique about our parabola is that the line goes down and then it reaches a certain point and then it turns back around. So when we're talking about this point, it's the turning point. Quite literal in its name. It's the point where the graph turns back around. When we're looking at this point here, this point 0C, what is that point? The y-intercept. Fantastic. So these graphs have still got a y-intercept. Now, what we're particularly concerned with is the x-intercepts. Because when we're solving, that's actually what we're solving for. So when we make this equation equal to 0, that 0 is where the y normally goes. So when y is 0, that's our x-intercept. So when we're solving an equation that's equal to 0, we're solving for the x-intercepts. So when it says solutions, the solutions are our x-intercepts. Now, we don't always have to have 2. Sometimes we have 1 and sometimes we have none, depending on where the graph is. Okay, so we are going to look at a few graphs and solve them by looking at them. So I've got my first graph, x squared plus x minus 2. Now, you will definitely need your calculator for today. I'm not expecting you to sketch these by hand. So what I want you to do is grab out your calculator and head into graphs. Now, once you're in graphs, up here where it says f of x, that's just the function in terms of x. That's basically the y. I want you to type in that x squared plus x minus 2. So this equation for 1a that I've got here, I want you to type that in, but without the equals 0. Just the equation, no equals 0. And then it gives you the parabola that we're looking at. So when it has the bar at the top with f of x, type in your equation x squared plus x minus 2, this first one, 1a. Okay, so as we can see from our graph, it has 2 x-intercepts. One over here on the left and one over here on the right. Now, when you're thinking about these graphs, perfect. When you're thinking about these graphs, I want you to note, okay, I've got one of my x-intercepts should be negative because it's on the left, it's on the negative part of the x-axis, and one is on the right, so it should be positive. Now, the reason it's important to think about these things even before you solve is so you know what kind of answer you're aiming for. Because if it's not in the ballpark, like say you get 2 positive solutions, maybe you've typed your graph in wrong, maybe you've calculated something wrong. You want to be able to see what kind of answers you're expecting before you even get those answers. So I'm expecting 1 negative solution and 1 positive solution. Now, the way I want you to solve this on your CAS, and there are 2 ways, but first we're going to start with graph trace. So to get there, you want to click on menu, then you're going to go to number 5, which is trace, and then you're going to go into graph trace. Now, this little dot picks up all the points on the graph. So right now, it's sitting on my y-intercept. How do I know that? How do I know that that point that it's sitting on is definitely the y-intercept? Well, it is going through the y, but I can't be sure because the dot is quite big. How I am sure is because down here on the right, it gives me the coordinate. And so because x is 0 at that coordinate that it gives me, I know that I've definitely got the y-intercept. So if you need to find the y-intercept when you're drawing these, you can always get it on the graph trace. Now, to get both of our x-intercepts, I'm going to go to my left one first in the negative. I'm going to press that left button and I'm going to move that dot along until I get to here. So it comes up with 0, which means that I've reached an x equals 0 point, but it also gives me the coordinate down here, -2 and 0. So one of my solutions for x is now x equals -2. So I've got one of my solutions. From this point, I've got x equals -2. Okay, now let's come back. I need the other one. So now I'm going to go to the right. I'm going to keep clicking that right button until I get to my next one, which I can see is my next x-intercept is at the point 1, 0, which means that my solution is x equals +1, which is pretty in line with what I was expecting. I was expecting one negative and one positive. Okay. Now I'm going to type my second graph in. Now, you can replace the one that you've got. So instead of creating a whole new document, you don't need to do that because I've seen some people do that a lot. You can either double click on the page and it will bring up a new bar and then it will graph both at once. I don't recommend that because it can get pretty full. What I like to do is double click on the F of 1, the one you've already got, and it will bring that bar back up. Like put your cursor over it, double click on it, and it should bring you up F of 1 of x and then the function you typed in. So I'm going to backspace that and put in my new function, which is 1b, the 2x squared plus 4x minus 5. You want to double click on the function that you've got, the blue function. And then press enter and it'll give you the new function. Now, I have got a bit of an issue. I can't see my turning point. I can't see where the graph turns around. So I'm going to need to zoom out. It's too zoomed in. My graph is too big. So you would have typed in a second one. That's okay. That's fine. As long as you know which one is which, that's fine. So if I get this problem where I'm too zoomed in, you're going to go to Windows Zoom, and then you can click. A few of these work, to be honest. You can type in Zoom Fit, and then it'll give you all the important points in one graph, or you can go into Menu, Windows Zoom, and zoom out, and then it'll bring up a little magnifying glass where you can keep clicking to zoom out as much as you want. I like Zoom Fit because it does it straight away. Okay, so now I've got my graph. I've got all the important points. I've graphed it. I can see two x-intercepts, one in the negative, one in the positive. It doesn't always work out like that. It's just happening with these graphs. And I'm going to repeat the process. So this time, I'm going to go into Analyze Graph and click on 0. Now, again, as I said, there are multiple ways to get your solutions on this CAS. I'm going to show you a second one. So, Analyze Graph and 0. Now, it brings up this dotted line that you can move all over the place. What you want to do is you want to tell it where you're looking for where x equals 0. So, I'm going to put it between here and here, because I can see that my two x-intercepts are going to fall in the middle there. You're going to click into Menu, Analyze Graph, and 0. And then I'm going to click my upper one, so the right one. Great. Now it's obviously brought up a decimal. It's not going to give you exact values on the graph function. that you'll actually have to solve for by completing the square. But decimals are fine if we've asked you to solve it graphically. So with this particular one, it's shown me that one of my x-intercepts is 0.871. So that's one of my x-intercepts. And then my next one, if it wants to give me the other point. Sorry, I'm going to repeat my process again to get the other point. If you're wondering which one I prefer, it's graph trace. I just find it easier with that moving dot, but this is just another one. Yes. Yes, I'll give it to you in a second. Okay, so that's how we're graphing on the CAS. I recommend you use the graph trace function. So just a reminder on how we get there, it's menu, trace, and graph trace, and it brings up the moving dot. I just like it because you can get all your 4 important points in one go, your 2 x-intercepts, your y-intercept, and the turning point. You can just sort of move that dot along and get all the important points instead of clicking on a bunch of different functions. Okay, so looking down here, these are our examples of how we can get one x-intercept or no x-intercepts. So graphs like this, where it's just touching the x-axis, not passing through, is where we will get the solution of just one x solution. Down here, where it's not going through the x-axis at all, so where the graph has been moved too far up where it doesn't actually go through the x-axis, we're not going to get any x solutions. So remembering, we are going to look at something called the discriminant next lesson, but remembering last lesson when we did the quadratic formula and we said that if inside that surd it was a negative, it meant that there were no solutions, because you can't have a square root of a negative. That's when we end up with a graph like this, where it does not go through the x-axis at all. It has no x-intercepts. Okay. Alex, did I say you had a question? No? Okay. Cool. Okay. So heading over to this worked example 2, it's a worded question. So a golf ball hit along a fairway shows the path shown in the following graph. So we're hitting a golf ball, it obviously comes up and then goes down. So it follows the curve of a parabola. The height h meters after it traveled x meters horizontally follows the rule h equals negative 270, and then we've got our x squared minus 180x. We need to use this graph to find how far the ball landed from the golfer. So our golfer obviously is standing at 0. So if the ball landed here at 180, we need to find how far the golf ball went. Does anyone want to suggest an answer for me? And yes, it is as obvious as you think. 180, good, because we can see our 2 x-intercepts here are at 0 and 180. Yes, so 0 and 180 are the solutions. That 0 was where he's standing, so we infer that the 180 is where the ball has landed. Okay.